morning, class. Hope you're all doing well. You had a good night's sleep yesterday. Very good. Now we are going to study mathematics. We are going to study mathematics. Good. Now, yesterday in our previous lesson, we learned about the area of a two-dimensional object. And we said area is the total space occupied by a 2D shape. Now today, and we also learned that area is a square unit. So when we come to the area, we square the unit. So for instance, if our answer is centimeters, it becomes centimeter square. If our answer is millimeters, it becomes millimeter square. And if our answer is any of the units, we square the unit. That's what we mean by an area being a square unit. Now today we are moving on to calculate the area, the total surface area and volume of a 2D shape. Good. I hope you can see from the screen. Good. So we are going to look at the surface area and volume of a three-dimensional shape or figure. But for the purpose of today, we only focus on the total surface area of a 3D shape. Now, by the end of this lesson, we should be able to use the appropriate formula to calculate the total surface area of the following 3D shapes. The first one is a rectangular prism, and the second one is a cylinder. Now, guys, what are some of the examples of a 3D shape that we know? Miracle. Miracle talks about a rectangular prism. Miracle says you have a rectangular prism. Very good. Any other shape? James? Very good. James says we have a cylinder. I think James and Miracle are reading from the screen. Okay. Any other shape I can think about? Esther? Yes, Esther says we have a cone. Any other shape? George? A sphere is also an example of a 3D shape. Thank you. Now let us have a look at these pictures on the screen. Now the first one, what do you think is the name of that shape? George? Correct. That shape is what you call the rectangular prism. It looks like a rectangle but having 6 faces. It looks like a rectangle but having 6 faces. And I have a solid one that for us all to see over here. When we say 6 faces, 1, 2, 3, 4, 5, 6. It is having 6 faces. That is a rectangular prism. What's the name of the second one? Miracle? Correct. Miracle says the second one is a cylinder. And truly, that is also a cylinder. And fortunately, I have a cylinder here for us to see. It has this side is a circle, this side is a circle. And from this side to this side is what we call the height. So we are going to learn how to calculate the surface area of these two shapes that I have in front of me today. Now, before we continue, I want us to watch this video.
Shape and rectangular prism. Each two faces are different, so you have to count the area of spiadic cuboids.
Let's watch it one more time.
Let's begin and its angular prism area of spiadic cuboids.
Very good. Now from the video, what did the speaker tell us about calculating the area of this shape? Yes, George. Correct. The speaker said that to calculate the area of this rectangular prism, we need to calculate the area of all the faces and we add them together. But this is what I want us to do. Now we can see that from this rectangular prism that we have, we can see that this side is the same as this side, and they are opposite to each other. And then this side and this side are also the same. They are equal and they are opposite to each other. Then this side and this side are also the same, equal and opposite together. So definitely the area for this side will be the same as the area for this side. Then the area for this side will be the same as the area for this side. And then the area for this side will automatically be equal to the area for this side, since the sides are the same. Now we have learned that a 3D shape has 3 dimensions. It has the length, in particular to this rectangular prism. It has the length, it has the width, or the breadth, and it has the height. Very good. So let us assume that with this our rectangular prism, let us assume that this is our height and this is our length, sorry, and this is the height. To calculate the face or the area for this face, it's going to be the length plus the height. And we are saying that this side and this side are the same. So it is going to be 2 times the area for this side, which will give us the area for this side and that side. So we are going to have, I'm using TSA for total surface area. 2 into bracket, the length multiplied by the height. Then we come to this side. Already we have agreed that this side is the width and this side is the height. So the area for this side is going to be the height plus the width. The height plus the width. And how many faces are they? 1, 2. So it's going to be 2 multiplied by, or 2 into bracket, height multiplied by the width. Plus, we come to this side. This side becomes our length, so it will be like this is our length, and this side is our width. So the area for this side is going to be the length and the width. But there are how many? 2. This side and this side. So 2 multiplied in brackets, the length multiplied by the width. So basically, the formula to calculate the total surface area of this shape is going to be 2 multiplied by the length and the height, close the bracket, plus 2, we open bracket, height and the width, we close the bracket, plus 2 into bracket, the length and the width, then we close the bracket. Why are we adding them? We are adding them because we are saying total surface area. And in mathematics, when we say total, we are referring to addition. Very good. Now, before I continue, do we have any question? Before I continue, before we do any calculation, do you have any question to ask based on the formula that we're putting on the board and our previous knowledge in mathematics? Yes, Miracle. Very good. I like that question. Miracle is asking that if the units of measurement are not the same, can we still calculate the total surface area? For instance, what Miracle is asking is that if our length given is in centimeters and our width given is millimeters and the height given is in centimeters, Miracle is asking, can we calculate the total surface area of such a figure? And anyone to answer Miracle? Yeah, James. Correct. James is saying that we can still calculate the area or the total surface area of this shape, but we must first ensure that all the units of measurement are correct or are the same. In other words, what James is saying is that we need to change the width from millimeters to centimeters. That is the only way we can calculate the total surface area of this shape. Very good, James. I like your answer. So what I'm trying to put across here is that, let me explain further what James said. We cannot calculate the surface area of this shape or of this shape if the units of measurement are not the same. It will be an irregularity. It will be wrong on our side. So before we calculate the surface area, we should ensure that all the units of measurement given are the same. In that all dimensions, the length, the width, and the height must all be in the same unit of measurement. So for instance, if the length and the width and the height are all in millimeters, they must all be in millimeters. If they are in centimeters, the three of them must be in centimeters. Are we good? That's like your question answered. Thank you. Now let us have a look at this example. Now we are going to look at a practical example to calculate the surface area of this box. Assuming that the length given is 8 centimeters, the height is 5 centimeters, and the width is 4 centimeters. What will be the total surface area of this particular box? And that's what we're going to calculate on the board right now. Let's make our calculators and our writing pencils ready. Our length is 8 centimeters, our height is 5 centimeters, and the width is 4 centimeters. I'm using L for length, H for height, and then W for width. Now, from our formula that we wrote in the board, we said total surface area is equal to 2 of length multiplied by W plus 2 of length multiplied by height plus 2 of height multiplied by W. So we now put in the values that have been given to us, or we substitute the values in the given formula. So wherever we see L, we put 8. Wherever we see W, we put 4. And wherever we see H, we put 5. Now let us do it together. So our 8 multiplied by 4 very good. So you can see that we have substituted in the values correctly. Wherever there was L, we put 8. Where there was H, we put 5. Where there was W, we put 4. Now, let's take our calculators. From our basic mathematics, we do what is in the bracket first. So, let's take our calculators. What is 8 multiplied by 4? James? 32, correct. We close the bracket. 8 multiplied by 5 gives us miracle. Miracle is 40. That's correct. And then 5 multiplied by 4, Edwina. Good, Edwina says it's 20. Very good. So now that we have done what is in the bracket first, we multiply what is in the bracket with what is outside the bracket. So 2 multiplied by 32 will not give us 64. Plus 2 multiplied by 40 will give us 80. And then 2 multiplied by 20 will give us 40. Now we add them all together. 64, do it. I'm also doing it on my calculator. 64 plus 80 plus 40. Esther, what did you get to the calculator when you added? Esther said she got 184. Miracle, you also get 184. Correct. Meaning that I also have 184 this side. So our answer is 184 centimeters squared. 184 centimeters squared. Is it understood? Are we fine? Are we sure? Can we do another example? Correct. Let's do another example. This time around, you do it yourself and I'll come around and check. Our second example is that our length this side is 9 centimeters, our height is 4 centimeters, and the width is 5 centimeters. I want you to do it by yourself. I'll come around to check before I also do it on the board for all of us. When you finish, raise your hand, you call me, I'll come and check. Miracle, you finished? Okay, Miracle, give us your answer. Miracle says you have 202 centimeters. Okay, let me write it here. 202 centimeters squared. We all have finished. Peter. Peter also got 202 centimeters. That's fantastic. Very good. Who else has finished? Okay, let me come and check. Mary. Like I'll be sure of the answer. Yeah, Mary has also got 202 centimeters squared. Now let us all do it together on the board and see if you are going to get 202 centimeters. Now, total surface area is 2LW plus 2LH plus 2HW. So whenever we see L, we put in the values. So 2 multiplied by 9 multiplied by 5 plus 2 into bracket 9 multiplied by 4 plus 2 into bracket 4 multiplied by 5. This gives us 45, 2. This gives us 36, 2, and this gives us 22. Now we add them 90 plus, what is 2 by 36? 72, correct. And then 40. And that gives us 202 centimeters squared. That gives us 202 centimeters squared. Very good. I hope now we understand what we have done so far. We have calculated the surface area of a rectangular prism. Now we are going to move on to how to calculate the surface area of a cylinder. Now, like I said, a cylinder has two sizes. This side, and this side. The area for this side is equal to the area for this side. So if you tell me the area for this cylinder, we calculate the area for this side, multiply it by 2. We are multiplying by 2 because this side and this side are equal. Then when we finish, we write our answer down, then we take the area for this side, multiply it by the height, and that gives us the surface area of a cylinder.